Monitoring air pollution using pollen grains of tree species in Mysore city. Dr. C. Hemavati, Department of Botany, Government First Grade College for Women, Vijayanagara, Mysore. Air pollution is essentially an urban phenomenon. It has assumed alarming proportion, especially in the developing countries. The effects of air pollution are diverse and numerous. Air pollution can have serious consequences for the health of human beings and also severely affects natural ecosystem. The most common pollutants emitted from auto exhaust are hydrocarbon, benzene, carbon monoxide, sulfur dioxide, oxides of nitrogen, ozone, and suspended particulate matter. The suspended particulate matter is of major concern as it constitutes about 50% of the total air pollution load and is also the main cause for number of severe respiratory diseases. Plants are very sensitive to air pollutants when compared to man, animal and material, resulting in extensive loss of agriculture and lasting changes in ecosystem. Studies on effect of air pollution on vegetation provide an important basis, particularly to adopt preventive measures in pollution control. Plant reproductive organs are very sensitive to air pollutants, hence the present work was undertaken to assess the impact of air pollutants on morphological changes of pollen grains of avenue trees in the historical city of Mysore. Pollen has great advantage in biomonitoring atmospheric pollution. They can be stored in adequate quantity in viable condition for a longer time. They are relatively more sensitive as compared to leaves and other organs. Biomonitoring consists of the use of responses of individual plants or plant associations at several biological organization levels in order to detect or predict changes in the environment and to follow their evolution as a function of time. Some plant species are sensitive to single pollutants and to a mixture of pollutants. The present investigation aims at studying the effect of air pollutants on pollen germination and pollen tube growth of roadside tree species Polyalthia longifolia, Samania saman and Swettinia mahogany. Growing at Fountain Circle, one of the busiest traffic intersection in the city of Mysore, Karnataka. The tree growing at Mahadevpura, 20 kilometers away from the city with negligible traffic served as control. Materials and methods. Ambient air quality monitoring data of Mysore city was obtained from Pollution Control Board, Mysore. Monitoring was done at major pollutants, namely SPM, sulfur dioxide, oxides of nitrogen, using high volume air sampler. In vitro germination studies also conducted. Pollen samples from tree species were collected both at control and polluted area during the flowering season. Pollen viability test using FCR was done to assess the viability of pollen of the three tree species following the method of Heslop and Harrison. In vitro germination test, pollen was cultured using Brubaker's Quax medium 1963. To culture the pollen, hanging drop method was followed by Shivana and Rangasamy method. Percent germination of pollen and length of the pollen tubes in 10 microscopic field was measured with an ocular micrometer. Mean pollen tube length, total length of the pollen tubes, the values were expressed in micrometer. Results. Ambient air quality monitoring shows the levels of pollutants SPM, oxides of nitrogen, oxides of sulfur were within the permissible limit prescribed by the Central Pollution Control Board, New Delhi. In vitro germination studies shows In the polluted area, the pollen viability test and percent germination and pollen tube length. The present investigation, the fluorescein diacetate test was used to test the pollen viability. The viability results of the pollen from controlled to polluted area are represented in the table 2, shows percentage of 42, 50, 60 in polluted area, which is very less when compared to the control Polyalthia longifolia Samania saman and Swettinia mahogany. The pollen that fluoresces brightly when seen under fluorescent microscope was considered viable. It is clear from the study that pollen from polluted area showed decrease in the pollen viability in the tree species studied. So this is the graph showing percent pollen germination, mean pollen tube length of different avenue trees like Polyalthia longifolia, Samania saman and Swettinia mahogany. Photomicrograph of the pollen germination of Polyalthia longifolia, Samania saman, Swettinia mahogany. Correlation between pollutants and percent pollen germination of different plant species. Correlation between pollutants and mean pollen tube length of different plant species. Correlation shows significant at 0.01 level and 0.05 level. The present investigation shown the possibility of using pollen has bioindicators of air pollution. Numerous studies have been devoted to the impact of air pollutants on pollen, but only few works are available on the use of pollen to evaluate the atmospheric pollution. Pollens are very sensitive to air pollutants and have been used for air pollution. Fedetto et al. Have also observed sulfur dioxide induced reduction in pollen viability, size and shape of pine pollen grains. Pollen used as bioindicator does not indicate the level of pollutants but measures their biological impact and can therefore provide information on potential adverse effect of pollutants on living organism. This direct assessment of risk by bioindicator method is of greater importance compared to physicochemical methods. However, plant bioindication method will never be a substitute to physicochemical methods for air pollution studies, but they constitute complementary method as they provide essential information on biological impact. Thank you.